Welcome back to Aliens Space Education Podcast. My name's Andy, your host. If you want to learn more or catch up on anything want to learn more about everything on here, please go to spaceforalleducation.com. It's available and there's a load of free stuff on there you can happily learn about. Today's celestial journey, we are going to spotlight on the Nebulas and their wonders, an interesting cosmos mystery, as it were. Nebulas are stellar nurseries where stars are born, remnants of star deaths, and the dynamic clouds of gases and the dust that contribute to the fabric of the universe. They're colourful, they're bright, they're wonderful, and they have loads of different things. Now, I do apologise from now on if you hear any strange sounds during these podcasts. It's because I now have an amazing little doggy called Holly. She's a British bulldog, and she may interfere sometimes, so I do apologise. Okay, so let's start off on our cosmic journey with what is a nebula? To start, let's define what a nebula is. The term nebula comes from the Latin word for cloud, and that's essential to what a nebula is. It's a vast cloud of gas and dust in space. It's clouds, so clouds are water vapor, as we know from our own Earth, our own planet. And dust, as you know, you can get dust storms, you can get dust storms and things like that. So you mix the two together, you're going to get a variety of different clouds. These clouds can vary greatly in size and density, okay? And they're often the sites of intense cosmic activity, which means they're usually born from a star of some description going supernova, and all that dust is expelled and gas and everything goes everywhere, and that's what a nebula is. However, because they're there, all that can then create new stars, new planets. So, stellar nursery, let's go back a step. Nebulas play several crucial roles in the universe. Starting off with one is the stellar nursery. Nebulas are the birthplace of stars. Within these clouds, regions of high density collapse under their own gravity to form new stars and planetary systems. It's pretty safe to say that every star has at least one planet around it. So it all comes from stellar nursery. Remnants of stellar deaths. These massive stars reach the end of their lives. As they explode, the supernova disperse their outer layers into space. These remnants can form new nebulas. Not all of them do, but a lot of them do. Your interstellar mediums. Nebulas contribute to interstellar medium, which is the matter of exists in the space between stars. The matter is recycled into new stars and planets. So it's more the gas is all sent out with a little bit of dust to create the planets. And there are different types of nebulas, each with their own unique characteristics and significance. So the types of nebulas, what are there? We've got emission nebulas. Emission nebulas are clouds of ionized gas that emit their own light, and they are often vibrant, colourful due to ionized of hydrogen atoms by ultraviolet radiation from nearby hot and young stars. The most famous example is the Orion Nebula, located in the Orion constellation, of course. It's one of the brightest and most studied nebulas in the sky. It's also one of the closest regions of massive star formation to Earth. So right on our doorstep, we do have this Orion Nebula forming new stars, forming new planets, maybe even life, right very close to us. Emission nebulas can be enormous, spanning hundreds of light years across. The light they emit gives them their stunning, colourful appearance, often displaying shades of red, pink, and green. You know from using light and you send it, and as it passes through raindrops, you get a cloud. Same thing. Light passes through these nebulas, the light is refracted, and we see different colours. Refraction nebulas don't emit their own light. Instead, they reflect light from nearby stars, just like I just explained like the other ones. These nebulas often appear blue because blue light scatters more effectively by dust particles in the cloud. An example of a refraction nebula is Pleiades Nebula, Pleiades, which is associated with the Pleiades star cluster. Again, if you know where these are in a star, it makes it really easy. If you know the stars, constellations, you know where they are in the sky, it makes it really easy to see. The light reflection by these nebulas give them serene, glowing appearance, contrasting with more intense colours of the emission nebula. So depending on how the light is reflected, not just from one star but from multiple stars around it, can change how that light looks. But you're looking at more bluish one. Okay, dark nebulas. Dark nebulas are dense clouds of gas and dust that block light from objects behind them. These nebulas appear as dark patches against the backdrop of bright stars or emission nebulas. As a well-known example is the Horsehead Nebula, located in the Orion constellation. Dark nebulas are often regions where stars are being formed, hidden within dense clouds of material. They are crucial for understanding the process of star formation because they conceal the early stages of star development. So because we can't see how they're forming, we don't know how many there are, and we have to wait for that light to burst through the darkness so we can see it. Then we have planetary nebulas. Planetary nebulas are not related to planets, but they are the shells of gas ejected by dying stars, where the stars, like the sun, our sun, reaches the end of its life. It sheds its outer layers, creating a glowing shell of gas around the remaining core. The core becomes a white dwarf, and the expanding shell forms a planetary nebula. Examples include the Ring Nebula and the Helix Nebula. These structures often exhibit beautiful symmetric shapes and are rich in elements such as carbon, nitrogen, and oxygen, exactly what we need for our life. So, a planetary nebula, even though it's a white dwarf star, our sun will become this eventually. It may create new planets, it may not, but the outer shell sends out a lot of dust and the carbon, nitrogen, oxygen needed to create new life as we know it. The life cycle of nebulas. To understand the full impact of nebulas, it is important to consider the life cycle. Nebulas undergo significant changes throughout their existence, so they do change. Most nebulas form from accumulated gas and dust in the interstellar medium. These regions of high density can collapse under their own gravity, forming a protostar and a surrounding protoplanet disk. The process can trigger the formation of new stars and possibly a planetary system, or maybe just one planet. We don't know how many planets because they're all different. Then you have an active star formation. During this stage, the nebula is actively creating new stars. The intense radiation from young hot stars can ionize the surrounding gas, creating an emission nebula. This is where we can see the nebula at its most vibrant and energetic. The interaction between the newly formed star and the surrounding gas can lead to the formation of complex structures and shock waves. So it can ripple through, and also these shock waves will create a gravitational movement. Not only that, if there's dust and rocks, maybe even asteroids, they can then change their trajectory, spin to create planets. This is the sort of thing that can happen, but who knows? We're not fully there understanding it. These are just some of the theories. Mature nebulas. As a star within a nebula evolves, they can change the nebula's appearance. Some stars may explode as supernovae, very young, but they will. Some go very early, some go very late. Dispensing their material into space, contributing to the formation of new nebulas. These nebulas can also be sculptured by interstellar winds or stellar winds and radiation pressure. So even though there may be new storms forming, inside a nebula, they can still die inside a nebula and create more dust and gas, changing how the nebula looks, but also creating new vibrant colours and creating new different things that we can see. Eventually, nebulas can dissipate as the gas and dust are dispersed into space. The materials from nebula can be recycled into new stars, planets, and other cosmic structures. The remnants of the nebula might become less visible as they mix with the interstellar medium. So just like if you spread water, as the thinner it goes, it disperses out. Just like a cloud, the thinner it is, the more you can see through it, the lighter it gets. The thinner it gets, the lighter you can get through, the more it goes out, the more it dries up, the less you see. That's the easiest way I can describe this. It disperses out. And stars do that, nebulas do that. Famous nebulas and their significance. Several nebula have captured the imagination of astronomers and the public alike due to their beauty and significance. We've already said the Orion Nebula, one of the most well-known nebulas, the Orion Nebula, is located in the sword of the Orion constellation. It is a stellar nursery where new storm stars are forming, and its proximity to Earth makes it an excellent target for study. Its key area for understanding star formation and the early stages of stellar evolution. So we're understanding stars formation right on our doorstep from the Orion Nebula. Then we have the Crab Nebula. The Crab Nebula is a remnant of a supernova explosion observed in 1054 AD. It's an example of supernova remnants and features a pulsar at its center. Studying the Crab Nebula helps scientists understand the end stages of massive stars and the nature of supernovae. So we've got two there, one at the beginning and one at the end. This is so cool. The Eagle Nebula. What's this one? The Eagle Nebula is known for its iconic pillars of creation. Image captured by the Hubble telescope is a stunning example of star-forming region. The pillars are dense columns of gas and dust, where new stars are being born, and the nebula's intrinsic structures provide insight into the process of star formation. Another one looking at the birth of stars, but lots of them. There are all nebulas in the universe. Nebulas are more than just beautiful structures. They play a vital role in the cosmos. They do star formation. Nebulas are the primary sites where new stars and planetary systems are being born. They provide raw materials and conditions necessary for the formation of new stars and planetary systems. Elemental recycling. Material ejected from stars and supernovae enriches the interstellar medium, leading to the formation of new nebulas and creation of elements essential for life, as we know it. Cosmic evolution. The processing occurring within nebulas influences the structure and evolution of galaxies. Understanding nebulas helps us piece together the broader picture of the galactic formation and evolution. So we're understanding the universe, more of it, not just the little bits that we see. By studying nebulas, astronomers can gain insight into the life cycles of stars, the dynamics of the interstellar medium, and the mechanisms driving cosmic change. Observing nebulas requires specialized techniques and tools due to the vast distances and varying luminosity. Okay, so one is you can use optical telescopes such as the Hubble telescope, capturing stunning images of nebula in visible light. The telescope can reveal the intrinsic structures and colors of nebula, providing valuable data about their composition and dynamics. So we can use the Hubble. We can use radio telescopes to detect radio waves emitted by nebulas. These observations can reveal the presence of cold gas and dust that is not visible in the optical wavelength, offering a different perspective of the nebula's structure and activity. You got to remember, as things collide, they create sound waves. We can't always hear them or see them, but radio telescopes can pick up these sound waves throughout the thing. We've got infrared telescopes. Infrared telescopes, such as the Spitzer Space Telescope, can penetrate through the dust and gas of nebulas and observe cooler regions and newly forming stars. Infrared observations are crucial for studying the early stages of star formation, so we're looking even further. You can use telescopes here on Earth. You can get one in the back garden. You can use in the back garden, but you might need a slightly more powerful one to get a good, clear image. Space missions and observatories, such as the James Webb Telescope, are designed to explore nebulas in various wavelengths, providing a comprehensive view of their properties and processes. Their missions help us understand the complex interactions within nebulas and their roles within the universe. Now, James Webb has released a lot of new images recently of some nebulas. It is well worth going to NASA, having a look at them. I will try and upload some onto my website for you, and you'll see a difference between what Hubble took and what the James Webb took, and you'll see a significant difference and amazing, beautiful pictures of our universe. As we wrap up our exploration of nebulas, it is clear these cosmic clouds are much more than just beautiful objects in the sky. They're the birthplaces of stars, the remnants of stellar deaths, and an integral component to the universe's structure and evolution. From the role of star formation and the impact on the interstellar medium, nebulas offer a window into the dynamic process of shaping our cosmos. Nebulas are crucial. They are the birth and death of stars. They are beautiful, they are fascinating, and the more we study them, the more we learn about how our own system could have come about. What nebula did we come from? What was in it, and what made us so unique that we live on this planet? Thank you for joining me on this episode of Alien Space Education. I hope you enjoy our deep dive into the wonders of nebulas. Please be sure to subscribe, rate, leave a review, ask questions. I'm happy to respond. In the next episode, we are going to be looking at we're going to have a little look at dark matter and dark energy. I think that would be a rather interesting one, considering talking about interstellar medium. It might help you learn a little bit more. Until then, stay curious, keep gazing up at the stars. Now look for nebulas. Maybe you'll find something fascinating there. There's always something new to discover when you look up. Keep looking up. Thank you.